So, hello everybody. Today we are going to discuss lecture 2 in mechanics subject for grade 2026. So, our new topic is this one, resolution of force into a force and a couple. Okay. So, what does this means? Okay, what does this topic signifies? Okay, so let's suppose I will try to explain with the help of figure that will make things much more easier. Okay, so let's suppose a body is there and two points are located on this body, point A and point B. Okay, so initially let's say a force is applied at point A, the load is applied, let's say call it P. Okay, and now the question comes, can we shift the load P from point A to B? Okay, so the answer is yes, we can do that. And how? That's the aim of this topic. So resolution of force into a force and a couple. Okay, so how we can change the point application of the load P from point A to B. Okay, so that's the objective of this topic. Okay, so let's suppose sorry, I will change the figure once again. So I'm taking the same body with the same points A here and B here. Okay, so now since initially the force is applied at point P, now I am applying it at point B. Okay, and the direction of this load P and this load P is same. That means if we draw a line parallel to the load P at point B. Okay, so these two lines are parallel. Okay, so initially the force is applied at point A like this P. Okay, so now we are removing out this force load P from point A and we are substituting it at point B. Okay, so now can we simply remove out this force from point A and put it over point B? So the answer is no. So how? So let's see. If B do some modification in the previous body, like see, if we add force P, then the net force on this body is 0, right? And but if you this then in this case the net force on the body is 0, but the original case of the body is that it having a force applied in this direction. Okay, so we are applying another force P. Okay, so now you can see the net force here is P minus P plus P. Okay, so it is coming as point, sorry, P. Okay, now if we do the moment calculation, moment equilibrium calculation, that is M, then initially let's suppose we are taking the moment balance with respect to A. So initially there is no moment, right? Like if we do P into the distance, right? But the distance of point A from point is 0, that's why it's coming as a 0. Now in this case if we do the moment calculation, let's suppose this is called second case. Okay, second case, then the moment coming is at with respect to the point A is P into distance, and the distance between A and B is, let's suppose call it L. So the moment is P into L, let's suppose call it M. Okay, so now as you see, when we remove out the force from point A and put it over the point B, one moment get created. Okay, one moment will be there on the body. So to balance out this moment, we have to apply what to say, opposite movement to counterbalance this. Okay, so we will apply a movement opposite to this, since the force we have changed from point A to point B, so with respect to point A, a moment is getting created in this direction, right? Which I have written over here is M. Now to counterbalance this, we have to apply a moment here opposite to that. So this is our original moment that we are applying, and this one is getting created. So for balancing this, we are made like this. Okay, so now the final body will look like something this. Okay, point A, point B. Okay, so now one force is applied here, that is P, and one movement must have to come. Okay, so now this body and that original body, I mean this point A and a force is there P. Okay, so these two body are equivalent, can be exchanged. Okay, so that's the main objective of this topic: resolution of a force into force and couple. So initially there is a force only applied at point A. Now we have resolved this into a force and a couple, force P and couple M. Okay, so I hope this one is clear to you. Now we are moving up to the second topic, that is the resultant of a system of coplanar forces. Okay, so as we have discussed in the previous lecture, what's the coplanar forces? Coplanar forces means the forces available or will present in a single plane. Okay, let's suppose this is the x-axis, this is the y-axis. Okay, so all the forces are present in this plane, xy plane. We call it as xy plane. Then that is known as system of coplanar forces. Okay, all the forces are present in the single plane. Okay, so how we are going to calculate the resultant of these forces. Okay, so that we have to see here. So the first thing is resultant sorry, parallelogram law of forces. Okay, parallelogram law of forces. Okay, so first we will discuss this. What's this? Okay, so suppose a force is there, uh, let me call it F1. Okay, another force F2. Okay, so I mean so the two forces are applied there at any point. Let's suppose call it O. Okay, so this both these forces are planar. That means both are available in a single plane. Okay, and they are making angle with respect to each other as theta. Okay, so now we have seen these two forces, so we will try through this method we will try to make it as a parallelogram. Okay, so let me get, so this one is okay, so we can call it as F2 and this one as F1. Okay, so why? Because these two things are parallel, right? And so the direction of F1 and this F1 would be same, and this line and this line would be equal. That's why both the direction and magnitude of this both F1 would be same. That's why we call it as a F1 as well. Okay, now if we could extend this one, then this angle again come as a theta, right? And so one second, I have to remove this F1 from here and I will add it here. So now see, if we see this triangle, let me name it PQR. Okay, so if we see this triangle PQR, so this one is F1, this one is theta. So what is this one? This will become F1 sin theta and this will become F1 cos theta. Okay, that's all. Now this thing we did, and now the question comes, what's the resultant of these two forces? Okay, so the resultant would be given as F1 square plus F2 square plus 2 F1 into F2 cos theta. Okay, so this is very simple to calculate. Let me show you how we can calculate this. So let's suppose sorry, here is my resultant forces. Let me call it RES. Okay, resultant. So see, this length would be F2, this one is F1 cos theta and this one F1 sin theta. Okay, so the from Pythagoras theorem resultant forces would be equal to, sorry, F1 plus F1 cos theta plus F1 sin theta cos square. Okay, and under root. So if you solve this you will get this equation. Okay, so this is pretty simple. Now we will have to find out. So let's say this resultant is making some angle sorry, with respect to F2, and that angle would be, let's say, call it alpha. So what should be the angle of alpha? That means from the horizontal line or the horizontal forces, the how much angle the resultant is making. Okay, so that we can calculate as a, let's see, tan alpha as a, okay, f1 sin theta. You can simply see that this triangle and you can get it, okay. And f2 plus f1 cos theta, okay. So this one is the angle for the resultant, okay. And another thing that we can say that, if we, okay, if we observe this triangle ORP, okay, ORP, this one, and you will use the sine laws, then you will get f1, okay, sine alpha, okay. And if this one is phi theta, then this will become 180 minus theta, okay. So is equal to resultant upon I mean sine 180 minus theta, okay, and equal to, so this force f2 and this angle, okay. So this angle would be, if this is 90, this is theta, this one is 90 minus theta, okay, and then this become 180 minus 90 minus theta, so it will become 90 plus theta, okay. So this will become f2 upon 9, sorry, sine 90 plus theta, okay. So this one is pretty easy. Like if you have to find the angle alpha, you can actually find out by using these two equations. No need to find doing these things, okay. This is the very simple thing, and you can use the Tangle's law, Tangle sine law, and you will get this equation, okay. That's why I have told this thing. These three things are very important, okay. 1 2 3. Now the second is a resultant of multiple forces acting at a point, okay. So in this case, let's suppose a point is there and multiple forces is applied, like f1, f2, f2, f3, okay. So the question come into mind how to deal with these types of problem, okay. So simply we make it a y-axis here and a x-axis here, okay, and we will resolve this f1 into by, like, f by summation of all the forces, all the result forces in y direction, that will become f1 cos theta 1 and f2 cos theta 2 plus f3 cos theta 3, okay. Similarly we can add it in horizontal direction in x direction, okay. So it would be like sin theta or something, okay. So that will be the, and if we calculate the resultant forces from these two equations, we will get f resultant equal to fx, this one, square plus fy square. Fy means this equation, okay, and we will get the resultant forces over here. And if we want to find, like, see, if we resolve all the forces, some resultant forces will come in like this, okay. This one is resultant forces, okay. Let me draw it here by x, and some resultant forces here, and suppose it's making an angle beta. So how will find the angle beta? Tan beta equal to simply f by upon fx, okay. So we have calculated f by here, fx here, and we will able to find the angle beta, okay. So this one is pretty simple, okay. So that's all. And now third point is triangles law, okay. So let me explain here. So let's suppose force is acting as P, another force is acting Q, okay. So if two forces are acting, and now you have to find the resultant of these two equations. So what you can do is simply just draw another line to make a complete triangle. Let's suppose call it R, and it should be in opposite direction. Like, see, all these forces is coming in this direction, right? P and then Q, but uh, ideally for completed triangle you should make R in this direction, but when you are computing the resultant of these two forces, you will make opposite to these directions, okay. So that's all, and this is known as triangles law, okay. So this is valid for two forces, okay. So, and from again, like, suppose if any angle is given, alpha, beta and gamma, okay. So using the same law, science law, you can directly write it as a py sine gamma equal to q by sine beta equal to ry sine alpha, okay. So this will make your things pretty easy. Okay. Okay. Now uh, fourth point is coplanar forces. Okay, so in coplanar forces, three conditions come. First one is collinear, concurrent, okay, and parallel. Okay, so concurrent case is same as this. Resultant forces multiple forces acting at a point. That means a single point is there and multiple forces acting like F1, F2, F3. Okay, so this will be same as in this case resultant of a multiple forces. Okay, so that's already discussed. So it's done, and we will see collinear. Collinear is pretty easy. Let's see. F line is there, some forces are acting F1, again some forces are acting F2, some opposite forces are acting F3. So how it will be the resultant? So resultant will be F1 plus F2 minus F3 if we are taking the this direction as a positive. Okay, so this will become negative F3. So that's a pretty simple in case of collinear. And now the another point is sorry. Okay, non-parallel type non-current current forces in a single plane. Okay, so let me slide these two things below and then we will discuss it. Okay, I mean, okay, 1 minute. I'm just sliding. Okay, now the fourth point is yeah, fourth point is coplanar parallel forces. Okay, so that means let's suppose a line is there and in a plane maximum plenty of forces are acting. Let's suppose P, Q, R. Okay, so see, if you want to calculate the resultant of these two forces, you can simply write it summation of F as we are taking this direction as a positive and this direction as a negative. Okay, so we will write as P plus Q minus R. Okay, now since these forces are parallel and not collinear, not concurrent. Okay, so we have to do the moment balance as well. Let's suppose we are doing moment balance from the point A with distance R, Q and P. Okay, so when we do the moment balance will come as uh, R into R. Okay, so this direction we are taking as a positive moment and this direction is a negative. You can take whatever direction you will want and you will get the same values. Okay, just with the negative sign or positive sign, that doesn't matter. Okay, so Q into Q minus P into P. Okay, this is the moment balance. So pretty simple. We have to do these two things for coplanar parallel forces. Okay, now a coplanar non-current non-parallel force system. Okay, what does this means? Let's suppose this is y-axis. Okay, this is x-axis, this is the origin. Okay, and let's suppose non-parallel forces. In the previous case we are dealing with the all the what to say parallel forces. Okay, A and sorry, P, Q, let's suppose R. Okay, so what we can't do directly the force balance and the moment balance. Okay, like we did in the previous case. Okay, so first we have to do is we have to uh, do the resolution in f direction, y direction and x direction. Okay, so this will become px, py. This is already in y direction, so no need to resolve this. This one is r. Okay, so we have to do resolution in r, y and rx. Okay, so how we will simply do it? Like we will do it if x all the force equation summation in x direction. So x direction all are in this direction. That means sorry, P by this one is Px. Okay, so the resultant force in x direction is Px plus Rx. Okay, and resultant forces in y direction is P by plus Q plus Ry. Okay, and the net moment balance we can calculate with respect to point O. So okay, so if we calculate the moment from the point O, the moment through these two line is sorry, these two forces is zero, right? Because the line of action is passing through point O. That's why the moment is 0. And for all three forces, we will get some moment balance, like Py into P plus Q into Q and Ry into R. Okay, so from the previous cases, the only thing differ is the force value, resolution of the forces in x and y direction. Okay, and now I have written one simple case like distributed force system. So the distributed forces or loads are forces which acts over a length, area or volume. On the other hand, a concentrated force, point load, is force which acts on a point. Okay, so what does it means, like if a body is there, suppose. Okay, so distributed forces means some forces will act overall, like over a surface or a volume. So like the forces is acting over the whole surface, but in case of point load or concentrated load, a body is there and the force is acting at a simple point. Okay, that is F. Okay, so that's the difference between distributed force system and concentrated force system. Okay, so I hope yeah, you are able to understand what I have told, what I have taught today. And so till then, keep learning and goodbye.